A tribute to Adriano Garcia by Jennifer Morse and Mike Zabrocki. I'm Dr. Samuel Allen Alexander, mathematician and philosopher, still here, and I'm reading this tribute article published in June 2026 in the notices of the AMS. Adriano Mario Garcia was born in Tunis on August 20th, 1928 to a Tunisian Italian family. He lived on a farm there until the end of World War II, then moved to Rome. After finishing high school, he was sent to the United States to live with relatives in Wyoming and eventually made his way to California, becoming a student of Charles Lohner at Stanford in the early 1950s. Following his PhD, Adriano held positions at MIT, the University of Minnesota, and Caltech before joining the nascent mathematics department at UCSD in 1966, where he spent the remainder of his career. He passed away in San Diego on October 6, 2024, at the age of 96. Adriano often recalled his training as a grad student at Stanford doing math with Lohner in a van overlooking the ocean. That induced what became a signature experience of almost everyone he worked with: sharing mathematics on the beach. Each afternoon he sat on the shore, yellow pads of computations strewn in the sand, drawing students and colleagues in with his enthusiasm for math. He shared so much more than his passion for math. Often as the sun set on a math session, he invited students and colleagues into his home for dinner. Surrounded by the warmth of his family, we learned to cook, were entertained with wild tales, and discovered how to enjoy life to its fullest. Starting in the 1960s, Adriano supervised 36 PhD students over the course of 6 decades. Even after officially retiring from UCSD in 2013, he remained research active, advising at least 5 more students as an emeritus professor. His 90th birthday was celebrated with a thriving math conference on the beach in La Jolla. Adriano's work spanned multiple areas, beginning with ergodic theory and probability, and ultimately finding a home in algebraic combinatorics. Shining throughout his career is his insistence that deep mathematics should feel elementary once properly understood. Oh, yes, I 100% agree with that. Garcia's early work on Bernoulli convolutions uncovered deep connections between algebraic structure and analytic regularity in random beta expansions. For beta in the open interval from 1 to 2, the Bernoulli convolution nu beta equals summation epsilon k in the set 0, 1, delta sub sigma bigger than or equal to nu beta equals sum epsilon k in the set 0, 1 of delta sub sum k bigger than or equal to 1 epsilon k beta to the minus k describes the distribution of the random series sum k bigger than or equal to 1 epsilon k beta to the minus k. The partial sums Sn equals sum 1 less than or equal to k less than or equal to n epsilon k beta to the minus k for epsilon k in the set 0, 1. Typically take 2 to the n distinct values, but for certain algebraic numbers beta, many coincide. Erdős showed that for a Poisson number, an algebraic integer bigger than one whose conjugates all lie strictly inside the unit circle, these overlaps are so pervasive that nu beta is singular. By contrast, Garcia studied a class of algebraic integers now called Garcia numbers, for which nu beta is absolutely continuous with bounded density. These have constant term plus or minus 2, and all conjugates strictly outside the unit circle. Garcia's key insight was to measure the collision rate of the sums Sn through what is now known as the Garcia entropy. Entropy of beta equals limit as n goes to infinity. Entropy of Sn over n, where entropy of Sn is the Shannon entropy of Sn. In the Poisson case, conjugates inside the unit circle force systematic cancellations among the terms beta to the minus k, producing heavy overlaps and driving the entropy below log beta, a signature of singularity. For Garcia numbers, the algebraic separation of conjugates prevents excessive overlap, keeps the entropy at its maximum value log 2, and ensures that the measure spreads out enough to be absolutely continuous. Garcia's entropy-based viewpoint reveals that the analytic behavior of these measures is governed not by chance, but by number-theoretic properties of beta itself. It remains central to the modern theory, especially in the unresolved case of Salem numbers, where the behavior of nu beta is still mysterious. Already in his earliest work, Adriano displayed a knack for uncovering the structural mechanism that makes a complicated object behave as it does. That same instinct appears in the Garcia-Rodamisch-Rumsey inequality, or GRR inequality. This inequality provides a bridge between local increment bounds and global regularity. Instead of relying on grueling pathwise estimates, it shows that suitable integral control of increments yields a quantitative modulus of continuity. This deterministic result underlies many regularity arguments for stochastic process sample paths. Garcia's structural insight also guided his contributions in ergodic theory. In that area, he's often remembered for a 3-line proof of an inequality due to Hopf, which surprised many in the field because earlier proofs of Hopf's result were 50 pages long. Quite an improvement there. Adriano had an ability to rewrite mathematics, stripping away clutter until the logic of a theorem seemed not just clear, but inevitable. This talent brought him true joy, and he published several books, including 2 co-authored with Omer Egecioglu while in his 90s. In the mid-1970s, Adriano's research trajectory shifted with when Elena Lascaux visited UCSD and sold him on the beauty of combinatorics. At the time, combinatorics was often looked down upon by mathematicians working in fields of higher stature that emphasized abstraction and sweeping generality. Adriano felt exactly the opposite. He was drawn to combinatorics precisely because its aim is a solution requiring minimal background, as elementary, transparent, and human as possible. That's a great job of articulating what attracts me to combinatorics too, personally speaking. This philosophy shaped the way Garcia worked. After many years, he described his style by coining the portmanteau manipulatorics, blending manipulation and combinatorics. Many of his papers prove combinatorial results through algebraic identities and direct calculation. One striking illustration of this approach is his joint work with his student Stefan Milne on a bijective proof of the Rogers-Ramanujan identities, a challenge for which George Andrews had famously offered a $50 prize. Funny that a $50 prize, 50 being such a small amount of money, can nevertheless be such a big deal. Their efforts led to the Garcia-Milne involution principle, a method that reduces a signed combinatorial sum to a positive one by systematically combining involutions with a bijection. Rather than producing an explicit bijection outright, the method iterates these maps to compute a non-explicit bijection between the target sets. They collected the prize, but more importantly, the method itself proved more influential than the particular identity it was designed to explain, as sometimes happens. Adriano found his intellectual home in algebraic combinatorics, where he collaborated enthusiastically on problems spanning everything from Cohen-Macaulay posets to McMahon partition analysis. Amid this breadth of interests, there was one direction that captured his attention and remained at the forefront of his mind for the rest of his life. Adriano invited Ian MacDonald to lecture at UCSD in 1988. There, MacDonald explained how Kevin Cottle's work on a generalization of Selberg's integral gives rise to a mysterious family of polynomials in rationals adjoin Qt adjoin x1, x2, ... MacDonald showed that these polynomials form an orthogonal basis for the space of symmetric functions, but little else was understood. Nevertheless, MacDonald conjectured that when expanded in a shifted Schur basis, the coefficients k lambda mu of Qt lie in naturals adjoin Qt. The definition was so opaque that it even obscured the fact that the k lambda mu of Qt are polynomials in Q and T. Garcia was immediately intrigued and had an insight that added to MacDonald's work, inspiring combinatorialists, algebraists, and geometers for decades to come. He built on the use of SN representations via the Frobenius map of big V equals summation over lambda multiplicity of big V lambda in big V quantity S lambda. Garcia proposed constructing an underlying representation theoretic object starting from a Schur positive symmetric function. He introduced the modified MacDonald polynomials. Big H mu of x qt equals summation over lambda big K lambda mu of qt S lambda, so that MacDonald's positivity conjecture was recast as one of Qt Schur positivity, and he proposed approaching the conjecture that big K lambda mu of Qt in naturals adjoin Qt by realizing these polynomials as bigraded dimensions of Sn modules big D mu equals direct sum over Rd big D Rd mu, such that, what is Calaf again? The Frobenius map, such that the Frobenius map of big D mu which is defined as the summation over Rd of q to the rt to the d Frobenius map of big D Rd mu equals big H mu of x qt. He started with the q equals 0 case, where the big K lambda mu of qt reduced to the Kostka-Fulks polynomials. Garcia worked with Claudio Processi to give a new proof that big K lambda mu of 0t in naturals adjoin T by finding graded Sn modules, the Garcia-Processi modules, whose Frobenius characteristics are big H tilde mu of x0t. Adriano then worked with Mark Hyman to define bigraded Sn modules satisfying the equation 1, namely Frobenius map of big D mu equals summation over Rd q to the rt to the d Frobenius map of big D Rd mu. Adriano and Hyman defined big D mu as the subspace of the polynomial ring rationals adjoin x1 dot dot xn y1 dot dot yn spanned by all derivatives of a polynomial alternant big delta mu. This space is a Sn module under the diagonal action xi maps to x sub sigma of I, yi maps to y sub sigma of I, and they conjecture that the dimension of big D mu is n factorial and the Frobenius image of is a Macdonald polynomial. This became known as the n factorial conjecture. Armed with this conjecture, they expected to prove that the big K lambda mu of qt are in naturals adjoin qt within a matter of months. Instead, Hyman's contributions indicated a more complex picture where the determinants big delta mu are elements of the bigraded Sn module of the diagonal harmonics. Diagonal harmonic n equals the set of big P of xy in rationals adjoin x1 dot 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 xn y1 dot 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 yn such that summation I equals 1 to n partial rxi partial syi big P of xy equals 0 for all r plus s bigger than 0. I don't know what those partial symbols mean. Fueled by computer experimentation, Garcia and Hyman amassed identities and worked to connect the representation theory, combinatorics, and the symmetric function expressions involving Macdonald polynomials. It was in this pursuit that Garcia and François Bergeron discovered the importance of an operator nabla on symmetric functions that takes the Frobenius map of big D mu as its eigenfunctions. They conjectured that the Frobenius image of diagonal harmonics can be expressed compactly as del of En, where En is the nth elementary symmetric function summation I1 less dot dot less In xi1 times dot dot times xin. It was later discovered that del is part of a broader picture connected to knot theory and the elliptic Hall algebra. The dimension of the diagonal harmonics of n was conjectured to be n plus 1 quantity to the n minus 1, while the bigraded dimension of the sign representation in the diagonal harmonics of n gave rise to a qt analog of Catalan numbers. Catalan sub n of qt specializing to Catalan sub n of q1 equals summation over pi q to the area of pi, summing over all 1 over n plus 1 times 2n Juz n Dike paths pi weighted by area, a familiar statistic on the Dike path pi. In 2000, Jim Hagland introduced another statistic on Dike paths called bounce, and conjectured that Catalan numbers sub n of qt equals summation over pi q to the area of pi t to the bounce of pi. The del operator encodes all of this information in symmetric function identities. Garcia and Hagland worked together over the summer to give a manipulatorial proof of Hagland's conjecture connecting symmetric function identities with the combinatorics of Dike paths. Simultaneously, Mark Hyman was finalizing an algebraic geometric program that led him to establish the n factorial conjecture and the dimension of diagonal harmonics sub n. These developments initiated a research program that Adriano pursued for the rest of his career and more broadly launched the still thriving area of QT combinatorics. Adriano contributed his infectious enthusiasm to the field for more than 3 decades. He believed that the most profound truths were those that could be grasped with elegance and joy. Yes. Some of his colleagues and students share below their memories of how he touched their lives and shaped their careers. Michelle Wax. I was one of Adriano's first combinatorics students at UCSD in the mid-1970s. He was an extraordinary teacher, and since he was also renowned as a leading researcher in analysis, I hoped he might become my advisor in that field. Before I got up the courage to ask him, he invited me to his office to share ideas he had about simplifying the proof of the Hoot-Tucker algorithm for optimal binary search trees. I was surprised. This wasn't real analysis. I didn't know that Adriano was transitioning from analysis to a field called combinatorics, where he would become one of the world's foremost leaders in algebraic combinatorics for almost 50 years. I worked on Adriano's binary search tree problem and had a breakthrough. His ideas led to a new, simpler algorithm for constructing optimal binary search trees. I was so excited to show him what I had done that I sat on the floor outside his office for what felt like hours waiting for him to arrive. Little did I know he was at his favorite place, the beach, which also happened to be my favorite place. What luck! The beach was Adriano's second office. His students and many distinguished visitors would find him at his encampment on the beach, where he would share his beautiful mathematical ideas and listen to theirs. He also shared his passion for riding the waves. He got a Maury boogie board when they first came out in 1975. In the years to come, he would bring a stack of them to the beach for his visitors. At his 91st birthday conference, a boogie board signed by all the participants was presented to him. The NSF program director remarked then that Adriano, at 91, was the oldest PI on an NSF grant in any scientific field. Wow. Adriano was an exceptional advisor. He was extremely generous with his time and ideas. His excitement about his students' work was a great confidence booster and motivator. From the 1970s to the late 1980s, Adriano's pioneering work helped shape the field of algebraic combinatorics and made him one of its true founding leaders. So many of his ideas he introduced during that period continue to influence the field today. I'll mention just a few threads from that time that have had a deep and lasting impact on my own work. Adriano's early research on Q analogs and symmetric functions, much of it with Ira Gessel and Jeff Remmel, laid the groundwork for his later celebrated work with Mark Hyman on Macdonald polynomials and diagonal harmonics. His work on Cohen-Macaulay posets, including his influential survey chapter with Anders Björner and Richard Stanley, played a central role in the early development of topological combinatorics. Adriano was much more than a mentor, colleague, and friend. He was family. There are so many stories I could tell. There were all those fabulous dinners he made. There was the time he fixed my suitcase by sewing the handle back on. The time he forgot to pack his Speedo on a visit to Miami. The times he taught me and my husband how to behave in Rome, and the time we got in trouble with the UQAM stuff for yelling at each other about a proof. Adriano's passion for mathematics and for life was legendary. What a profound privilege it has been to have known this remarkable man for so many years. Anders Björner writes, Adriano Garcia was my friend. I was proud that he often referred to me as his mathematical brother. Adriano started research and analysis in the 50s as a student of Charles Loerner and Marcel Rees, who were both at Stanford at that time. His proof of the mean-ergodic theorem from 1955 is considered by many the best way to understand that theorem. In the 70s, Adriano moved on to combinatorics, more precisely algebraic combinatorics, where he soon was recognized as one of the leaders in the field. Adriano and I started talking about combinatorics when we first met at an AMS General Math Conference in Columbus, Ohio in 1978. His enthusiasm for combinatorics was contagious, and our conversation continued at UCSD a few months later, what was to be one of many visits. His favorite seminar room was under a parasol at the beach in Del Mar, where even the most intellectual Parisian mathematician succumbed to balancing his notebook on a towel filled with sand. Adriano's beach seminars produced beautiful results. Among them is his work in 1977 with Michel Wax on optimal binary trees, and the construction in 1993 with Mark Hyman of the n-factorial conjecture. Of lesser importance, but dear to my heart, was the expository paper on Cohen-Macaulay posets that I wrote with Adriano and Richard Stanley in 1982. Adriano's students bear witness to the fact that he was a very inspiring teacher, always full of ideas, always asking questions. His enthusiastic style of mentoring encouraged everyone to believe in their abilities. The gratitude of Adriano's students will be his legacy. Finally, let me say that Adriano was at the core a passionate and proud Italian. This flavored his life and his cooking. His secret was adding handfuls of salt to the spaghetti water. Only espressos and Speedos, never American coffee or beachwear. Mark Hyman writes, I got to know Adriano when he was seeking my permanent position after being a postdoc. When I was seeking my first permanent position after being a postdoc. He ended up recruiting me to UCSD, where I stayed for 10 years before moving to Berkeley. That period, and after, was for me a time of wonderfully fruitful collaboration with Adriano and others in his circle. Adriano and I both attended the combinatorics program at the Mittag-Leffler Institute during the winter quarter of 1992, my first year at UCSD. Adriano's wife, Diane, and young daughter, Gabriella, were there with him. After a while, when the grey Stockholm weather had begun to drive Adriano crazy, he announced that he was taking his family to Rome for a week and that I should come too. That was when he introduced me to Claudio Procesi and taught me to drink espresso. Another time, the four of us made a driving tour the whole length of Italy. Adriano loved company, knew and loved Italy, and loved showing places he loved to others. The whole excursion was a fabulous experience. We got on well together with just one quirk. Both Adriano and Diane were prone to car sickness. Things were fine when Adriano drove, as the driver doesn't feel it, and Adriano had learned to make adjustments to keep Diane happy. But naturally I needed to share the driving, especially since Diane was uncomfortable driving on Italian roads. So I was given 2 instructions. 1. Take all curves very slowly, and 2. Never touch the brakes. As personalities and collaborators, he and I were an odd match. Adriano was the epitome of gregariousness, while I tended to be solitary. Whenever the weather was good, he would set himself up in the afternoon at La Jolla Shores or Del Mar Beach. I spent a lot of time at La Jolla Shores myself as a child. Continuing. With his towels, folding chair, umbrella, bag full of math, and students. I didn't like to work in the sand and would only join him there occasionally. The way Adriano would describe our working style, he was the optimist and I was the pessimist. He would come up with one idea after another, thrilled every time to believe that this new idea must be the key to solving whatever we were trying to solve. I would then search for an example in which it didn't work. This, however, turned out to be an excellent way to collaborate, for when you open many doors, then shut the ones that lead to blind alleys, you eventually find the door that leads you to the place you want to get to. Elena Barcelo writes, We have been asked to celebrate Adriano's life while remaining brief. How can I do so when there's so much to celebrate? By celebrating one aspect of his life at which he excelled, mentoring. I first met Adriano in 1984 as I arrived at UCSD to begin a PhD in mathematics, logic. Diane Favreau, a Quebecoise who later became his wife, had heard that a Quebecoise was joining the graduate program. She tasked Adriano to find me and bring me home for dinner. Adriano and Diane not only fed me, but also provided a friendship that was crucial in the first years of my life in the US and that lasted to this day. Adriano also took me under his wing. In those days, mentorship was not a common occurrence, and without his guidance I'm not sure I would have completed my study here. When I arrived in La Jolla, I certainly thought I knew everything there was to know about studying in the US. Of course I did not, and Adriano was there to help me without even having to ask. He started by teaching me cryptography so that I could become his TA. While doing this, he was also planting ideas about algebraic combinatorics. In those days, for me, combinatorics was all about arranging socks. Who cares? Discussing baseball. What on earth are they talking about? Or playing poker. What is a flush? I detested it all. Yeah, that's the flavor of combinatorics you get in a first-year undergrad class, I guess. There was absolutely no way I would go into combinatorics. Adriano could teach me cryptography. That was fun, but I would not become a combinatorialist. He was never fazed by this know-it-all attitude of mine. He would laugh and simply suggest that I take his algebraic combinatorics course. I did, and the rest is history, as the saying goes. And it was that Adriano not only taught me beautiful mathematics, but what it meant to be a mentor. Meet the students where they are, when they are ready, and without them having to ask. Adriano was ahead of his time. His unconditional embracing of students in the combinatorics community is one of the reasons our field is known for being friendly and mindful of all. Aaron Ram says, A reason to go to UC San Diego for a PhD. That man had fire, that man had culture, that man had passion, that man sparked electric energy, and I could learn mathematics from that man, and that after all was the point. In grad school, I failed my calls for the nth time. I personally only failed the calls once. The rules said I had to be kicked out of the PhD program. Garcia rose like a great Durga, riding a tiger and wielding weapons with many arms, fighting for my cause. It didn't make him many friends among his colleagues, but he won. I didn't get kicked out of graduate school, and my mathematics career had another chance. I was immensely grateful, but never dared to bring it up for fear that Durga might rise again. One Sunday I came up the elevator in the math building, and I could hear yelling down the hall. In trepidation and curiosity, I edged my way hesitantly toward the commotion. As I got closer, I realized that it was Adriano, a world expert in Schur functions, in Jeff Remmel's office, another world expert in Schur functions, screaming, "What's the definition of a Schur function?" I slunk cautiously and quietly to the stairwell and went quickly down the stairs. I learned an important mathematical lesson that day. On Sundays and Wednesdays, the definition of a Schur function might be different. It has been a very useful lesson in my work since that time. The phone rang at 7 a.m. on Saturday morning. "Aaron, are you up?" Like any proper grad student, I had been planning to sleep until 1:30 p.m. after a late night. Ugh. Before I could muster an answer, the voice continued. "I've been waiting for hours until it was a suitable time to call. You must come over right away. It's fantastic. I have to tell you all about it." I knew that meant that there was a wonderful breakfast in store for me and a couple of hours of exciting mathematics explanations. Sure enough, 45 minutes later, I was enjoying an aromatic double espresso, croissants, and eggs and fruit and cheese, and listening to the expostulations of how to modify Macdonald polynomials into the most fantastic object ever observed by humans. Garcia was always happiest when you're engaged in working together with him on what he was working on. It was in so many ways the most fantastic, amazing, and thrilling way to tantalize your mind. Nantel Bergeron writes, "When thinking about Adriano, countless dinner stories come to mind. He was passionate about life, and it was around the making and enjoyment of food that one got to know him more deeply. From stories of his childhood to tales about mathematics, Adriano was an open book filled with fascinating plots and anecdotes. I always felt that Adriano was part of my family and that I was part of his. Slowly, through these wonderful dinners, I was introduced to some of the most influential mathematicians of the time. I still remember the day Schutzenberger visited UCSD and Adriano wanted to cook dinner for the master. At the time, he was in transition between houses, so he used my apartment to cook. I was incredibly intimidated to host Schutzenberger. This was quite a something for me, and I must say it was the first time I felt that Adriano himself was also a little bit intimidated. Perhaps he even expressed it more than he felt just to make me feel at ease. I wouldn't be surprised. This would be so in line with his nature. Mathematics was always there, woven into everything. It is through mathematics that I discovered a very different mind. I remember him going through pages of computations. Sometimes I would follow line by line, only realizing at the end the scope of what we had done. I would always marvel at that moment. How did he do it? And again, he would make me feel comfortable, point to something I had done he found wonderful. I saw him get so excited about what those students around him had accomplished. Especially us, his students. In fact, that's how he recruited me to study in San Diego in 1987. We had worked on some small representation theory problems in Montreal, and since I had solved a minor question, he got all excited and convinced me to give up my plans to go into physics and instead study with him at UCSD. Luc Lapointe writes, I first met Adriano in 1995 while I was doing my PhD in physics at the Université de Montréal. I had never seen anyone before give a talk with such passion and enthusiasm, which was absolutely inspiring, and he was not afraid to make bold statements. I still remember that he said something along the lines of, "The analysts are the bad guys, who cares about convergence?" which truly resonated with me as a physicist. Adriano's generosity went far beyond just words of encouragement. The following year, he invited me to UCSD for I.G. MacDonald's lectures on double affine Hecke algebras. Adriano's influence on my career and research was profound. I spent the second year of my postdoc at UCSD. He convinced me to first spend 1 year in Marne-la-Vallée. At that time, there was great excitement and development about Macdonald polynomials and the n-factorial conjecture. I remember being especially thrilled about his science fiction paper with François Bergeron, which posited that the intersection of K-Garcia-Hyman modules had dimension n factorial over k. While I never formally collaborated with Adriano, I learned so much from him, especially in his art of manipulatorics. I wonder why they call that the science fiction paper. I also always felt his genuine excitement for my work, and his support often went beyond simple encouragement. He dedicated, for instance, countless hours shaping our first paper with Elaine Lascaux and Jennifer Morse on atoms, contributing invaluable insights to the introduction and overall presentation. My time at UCSD also meant a lot of time working at the beach, which I never fully enjoyed, and a lot of dinners at his house, which I always greatly enjoyed. I saw him less often after I moved to Chile in 2002. I remember a poignant moment during a 2006 visit to San Diego. He sadly confided that he was afraid that the end was coming, that he wouldn't be able to do mathematics forever as he wished. I was extremely moved, yet I couldn't find any words of comfort. Forever was probably a lot to ask, but never did I imagine that he would keep doing first-rate mathematics for more than 15 years. I have been fortunate to have met some incredible people, but Adriano was in a league of his own. Everything about him was larger than life. His energy, his enthusiasm, his passion, his humor, his cooking. I especially enjoyed my conversations with him as he had such a unique perspective on both life and mathematics, as well as some of the best stories I have ever heard. On a deeper level, he was the mathematician that I most wanted to impress, and I will terribly miss this driving force. Emily Circle. I met Adriano at the UCSD open house in 2011. From this one meeting, I knew I wanted him to be my PhD advisor. According to Adriano, doing math was the solution to all of life's problems. Yeah, I'll agree with that. And he couldn't imagine that anyone would feel differently if they gave math a try. When a friend announced he and his wife were getting divorced, Adriano decided to teach the wife some math. He said that doing math would make her happy and then they wouldn't need to get a divorce. He truly believed that anyone could succeed at math, and with the right attitude. He often told a story about redoing his driveway. Rather than pay a crew to demolish the old one, he threw a party for faculty and students. He invited everyone to have a turn using the jackhammer. Many would try for a minute or two and then give up. Some stuck with it and kept hammering, eventually breaking through the concrete. The students who stuck with it, Adriano claimed, were those who later wrote the best PhD theses. He was optimistic, proactive, and resourceful, tackling anything that caught his interest with determination. He taught himself how to cook without the guidance of recipes, based only on the memory of how his mother's food had tasted in his childhood. He learned programming while teaching it, back when the UCSD computer science department was new and in need of instructors. He said many times that teaching something was the best way to learn it yourself. Adriano is one of my favorite speakers. His math talks were chaotic, passionate, and inspiring. He always included colorful diagrams and animations. Even when talking about something for the 50th time, he would still get visibly excited, practically jumping up and down on the punchlines. His enthusiasm was irresistible and drew countless others to work on the problems that he loved. When I started grad school, Adriano was already in his 80s. Some people thought I was crazy to choose such an old advisor, but the people who said this had never met Adriano. Even with a bad back and a walker, anyone who knew him couldn't really think of him as old. The idea that he may retire soon was ridiculous. He was full of life and full of passion for math and food and music and travel. When he did eventually retire, many years after I graduated, he kept doing mathematics, working with students, swimming the ocean, cooking delicious meals, and living his life with joy. As we should all aspire to do. What an inspiration. Amazing guy. I didn't mention it, but I myself grew up in San Diego. I lived there from, probably around age 10 or 12 or so until age 17 when I moved out to join the U.S. Air Force. And I spent a bit of time at La Jolla Shores. In fact, this picture we see here, I'm trying to figure out whether that's La Jolla Shores. It could be. Anyway, I'm Dr. Samuel Allen Alexander, mathematician and philosopher. Please like, comment, and subscribe, and I'll see you in the next video.